safely to the Earth.
Tranquility Base here. The Eagle has landed.
Good morning and welcome to the Johnson Space Center in Houston, Texas. I'm NASA's Sandra Jones, and we're bringing you live coverage from Mission Control Houston of the upcoming Outbound Trajectory Correction Burn, or OTC-1 burn, following the historic launch of the Space Launch System from the Kennedy Space Center in Florida just hours ago. Today, we're in the White Flight Control Room, just across the hall from where you usually see us in the International Space Station Flight Control Room. The White Flight Control Room has been used before during some space station missions and during missions of Boeing's Starliner. Previously, this room was used for space shuttle missions and was also renovated in 2014 to support our use with the Artemis program. So, speaking of Artemis, earlier today, the Space Launch System blasted off from Pad 39B at the Kennedy Space Center in Florida at 12:47 a.m. Central, 1:47 a.m. Eastern. Following liftoff, solar arrays were deployed, translunar injection took place, and ICPS separation occurred. Since then, Orion has been in a coast phase. So let's take a quick look at a replay of that spectacular launch happening just hours ago.
The vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis I. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. SLS now traveling 607 miles per hour. Maximum thrust. Quiet here in the loops in Mission Control. The 4 core stage engines are throttling down ahead of passing through max Q.
And there you saw it, that beautiful launch in the wee hours of the morning with SLS lighting up the Florida Space Coast. Now, on your screen today, you see today's flight director, Rick LeBrode, who stepped in and is leading the team now, following Judd Freeling, who led the team during the ascent portion of the Space Launch System. Now, during liftoff, SLS produced 8.8 million pounds of thrust, propelling Orion toward what will be more than a 1 million mile journey to the moon and beyond in an elliptical orbit before heading back to Earth. Now that Orion is on the way to the moon following translunar injection, the next major milestone is the Outbound Trajectory Correction, or OTC-1 burn. This burn will fine-tune Orion's path to the moon and will perform a critical checkout of the Orbital Maneuvering System, or OMS engine, which is the main engine on the European Service Module. The outbound leg of the Artemis I mission is the portion between translunar injection and distant retrograde orbit insertion, which will take place later in the mission. This outbound trip will take several days, during which time engineers will evaluate the spacecraft's system. And following the outbound leg, Orion will fly about 80 nautical miles above the surface of the moon at its very closest approach, and then we'll use the moon's gravitational force to propel Orion into a distant retrograde orbit, traveling about 40,000 miles past the moon in this orbit, and this distance is actually 30,000 miles farther than the previous record set during Apollo 13, and the farthest in space any spacecraft built for humans has ever flown. But before we get to the moon, we need to have the critical checkout of the OTC, which will check out the Orbital Maneuvering System OMS engine. So to give us an overview of the OTC-1 burn, let's take a look at this video overview using the moon board.
All right, now let's talk about OTC-1, outbound trajectory correction number 1. So at this point, we've done our translunar injection, we're on our way to the moon. And to get there, we're gonna fine-tune our path, we're gonna make a couple of different burns just to make sure we're targeting the right direction. Now the first one is this OTC-1 burn, and really this is a critical test of that large orbital maneuvering system engine that's right here in the aft part of the Orion service module. That's really what's going to be doing our big pushing maneuvers, and it's critical for those flybys, the powered flybys of the moon, both the one that allows us to get to distant retrograde orbit and the one that comes home. Additionally, we have these auxiliary thrusters around the bottom. We have 8 of these that can provide some additional push to help out with this orbital maneuvering system engine. But OTC-1 is coming up. We'll likely make a number of these burns on our way out to the moon, and all that sets us up for essentially this slingshot that we see here before we get to the outbound power flyby. You can see that engine igniting here. Testing it on this burn is going to be really critical to making sure that it works there, and that's what's going to allow us to get into our nice stable orbit around the moon, where we can really test Orion out, put it through its paces. So coming up, OTC-1, the first in many burns using that European service module on this Artemis I mission.
And to talk a little bit more about that OTC burn that we do have upcoming, I have a very special guest joining me today. This is Brant Gast. He is a prop flight controller here in Mission Control. So thank you so much for joining me today. This has to be a really exciting moment for you.
Oh, it is. It's years worth of work. It's just a great thing to see we're off the ground in space.
Absolutely. It was so exciting to see that launch earlier. So as we look ahead, can you talk just a little bit about that OTC burn, what it is, what the purpose of it is?
Sure thing. So it really has 2 purposes. So the first one being that we are going to do a trajectory correction. So there we're going to correct dispersions or errors that we've gotten from, going off of ICPS or just being in deep space, effectively figuring out where we're supposed to be versus where we are. Second thing, as was mentioned, is checking out the OMS, the Orbital Maneuvering System engine. As a prop, that's very exciting. That's going to be the first time that we test out that big engine.
Great. And so what are some of the other major burns that will happen throughout this mission? Because this is really this first checkout of that main engine like you discussed, but we know there's going to be other burns that take place throughout Orion's mission to the moon and back home.
Yep, exactly right. There's 4 more burns that we'll do on the OMS. The first one is the OPF burn. That's the outbound power flyby. As you mentioned, it goes really close to the moon and essentially slingshot us into the distant retrograde orbit, but we don't get there just yet. Then we have the DRI. That's the insertion burn to get into the DRO. That burn will essentially put us in that elliptical orbit around the moon. We then have a couple of days, weeks, where we can test out all the systems. Then we have the DRD, so now we can depart from the DRO, put us back on the way home, and then the RPF, the return power flyby, essentially mirrors the OPF. So that way we come back, slingshot again, puts us right back on the way home.
That is definitely exciting, and even more exciting because we'll be on the air to cover many of those burns throughout the mission. So my very last question for you is, can you talk a little bit about your role as a prop during these burns and some of the things that your console team will be monitoring and looking for?
Sure. So just in general, flight controllers are there to make sure that the burn goes off well, or just in general that we get where we're supposed to go. For a prop, it's very exciting. As I mentioned, we're testing out our hardware. We are the owners of the OMS. Everything that we see from the pressurization system, the feed lines, the propellant itself, and then the thrusters, this is kind of our first big test of the system. So we're going to look at things like pressures, temperatures, everything that we know, hey, here's what our system is supposed to look like. We'll see that, and then we can coordinate with other consoles like the GNCs, the FIDOs, see if they got the answers that they wanted, and then obviously we coordinate with the flight director, and hopefully in a couple minutes here we'll say everything was good to go.
Yeah, Yep, very exciting indeed. We're about 21 minutes away from OTC-1, so I'll let you get back to it. I know you have some exciting work to do ahead of that burn, but thank you so much, Brant, for joining me, and good luck on that burn.
Excellent. Thank you very much for having me.
So we are now closing in on the 20-minute mark to that OTC-1 burn. Now, the OTC-1 burn, as Brant mentioned, includes a checkout of the orbital maneuvering system engine. The OMS engine is the main engine on the European service module and is located on the bottom of the service module. And so as you can see in this graphic here on the very bottom of Orion is that larger engine. That is the Orbital Maneuvering System, or OMS engine. This engine is built by Aerojet Rocketdyne and is the main engine, as I've mentioned, on the European service module, which provides the primary propulsion for Orion's major in-space maneuvers as it travels around the moon. And this engine provides about 6,000 pounds of thrust and is enabled to steer the spacecraft. That engine is actually on its first mission as part of Artemis I, of course, but is a repurposed Space Shuttle Orbital Maneuvering System engine that has flown in space before. The engine flying today on Artemis I flew on 19 space shuttle flights, beginning with STS-41G in October of 1984 and ending with STS-112 in October of 2002. And you can also see a few other engines around the OMS engine. Some of those are the auxiliary engines. There are 8 auxiliary engines. They are located on the bottom of the service module in 4 sets of 2. These provide about 100 pounds of thrust each and can provide steering during burns by pulsing on and off. There's also 24 smaller engines grouped into 6 pods which provide attitude control. They can be fired individually as needed to move the spacecraft in different directions or rotate in any position. So in total, the service module has 33 engines in all. Now, as we are less than 20 minutes away from the OTC-1 burn today, we did hear the flight director give a go, no-go poll for today's burn, and the team pulled go. Everything looking good ahead of this critical checkout of the Orbital Maneuvering System engine. Now, this burn will be relatively short, lasting about 16 seconds long. But the OMS engine can fire for as long as 16 minutes for certain burns. And we are hearing that the solar arrays on Orion are maneuvering into the correct position ahead of the burn upcoming in about 17 minutes from now. At this hour, we are now 7 hours and 28 minutes since Orion lifted off, and Orion is 40,695 miles away from Earth and 181,000 miles away from the Moon. As Orion continues its journey to the Moon as part of a 25-day mission to test out critical components as part of the Artemis I mission, let's take a quick look at a mission overview of what is to come throughout this mission.
Welcome to the moon board. We got this just in time for the first mission in Artemis, Artemis I, so let me use it now to take you through. As always, we're going to start off with a launch. In this case, 4 RS-25 engines ignite, 2 solid rocket boosters sending SLS and Orion skyward. On the way uphill, a couple of jettison events, things coming off of the rocket. One of the most visual will be these 2 solid rocket boosters coming off about 2 minutes into the flight after all of their propellant's gone. We also have 3 fairings protecting Orion on the way uphill, as well as the launch abort system that will come off. Now, after we get through all of the propellant in that giant core stage, we'll hear MECO, main engine cutoff. It will drop away, turning propulsion over to this, the interim cryogenic propulsion stage, or ICPS. It's going to make its first maneuver to raise up the lowest part of our orbit around Earth, really put us in a nice circular path around our planet. And while we're in Earth orbit, we can check out Orion, make sure its systems are functioning as we expect before we commit to sending it to the Moon. That happens here, the trans-lunar injection, to a 20-minute firing of this ICPS upper stage. And what that's designed to do is really give Orion enough energy to get out of low Earth orbit and make its way to the Moon. Shortly after that, the ICPS will separate. Its job pushing Orion is done. It has a couple of secondary payloads in here, some CubeSats that it'll deploy, ultimately sending itself on a path around the Moon before it escapes and goes into orbit around the Sun. Meanwhile, Orion, though, continues on its journey. It'll make some correction burns as it fine-tunes its path towards our lunar neighbor before we get into all the exciting stuff up close. We'll dip in for a 60 nautical mile flyby of the lunar surface using the engines on the European Service Module to push us around and into distant retrograde orbit, or DRO. That's this dotted line that you can see up here. This is really where we're going to learn about Orion while we fly around the Moon, about 38,000 miles off the lunar surface. And we call it retrograde as the Moon is heading in that direction. Orion will be heading in this one, opposite retrograde. Now, after we're done in that orbit, it'll be time to come home. We'll execute a maneuver to exit, do another flyby close to the lunar surface that commits us to coming home and fine-tuning our path towards the atmosphere. We'll make any correction burns on our way back as necessary before it's time to re-enter the atmosphere. Now, before that can happen, we'll have a spacecraft separation event. The service module, its job is done. It breaks away, ends up burning up in the atmosphere after carrying Orion to the Moon and back. What this does is reveal the heat shield, the large structure on the base of Orion. Testing this is our #1 goal for the Artemis I flight, because when we come back from the Moon, we're going to be moving at 25,000 miles an hour. That's 8,000 miles an hour faster than when you come home from the International Space Station. And what that's going to cause is this to heat up to about 5,000 degrees Fahrenheit. That's half the temperature if you were standing on the surface of the sun. So things will be very hot, but that heat shield does its job to protect the Orion capsule, which will be bringing our astronauts home at the end of these future missions. After we're through that fiery re-entry, parachutes deploy, Orion splashes down in the ocean. We'll have a U.S. Navy ship standing by with recovery personnel to pick Orion up out of the water and bring it in to the first flight in the Artemis program.
And there was an overview of what is to come and a little bit of what has already happened in the mission so far. Again, we lifted off from the Kennedy Space Center in Florida about 7.5 hours ago. And at this hour, we are nearing less than 10 minutes away from the OTC-1 burn. That OTC-1 burn includes a checkout of the Orbital Maneuvering System, or OMS engine. And this OMS engine is the main engine on the European service module, located on the very bottom of the service module. This burn is slated to last about 30 seconds long. And as we approach the OTC-1 burn less than 10 minutes from now, Orion is maneuvering into the proper attitude in preparation for this burn. Earlier, the solar arrays did a very similar maneuver. And before that, the flight director pulled the team here in Mission Control, and all were a go for today's burn. The key purpose of today's burn, besides checking out the OMS engine, is to correct any trajectory dispersions on this outbound leg of the mission. The outbound leg of the Artemis I mission is the portion between translunar injection, which occurred earlier today, and distant retrograde orbit insertion, which will take place a little later in the mission.
Flight Gene C.
And we did just hear that Orion is in the appropriate burn attitude. Everything continuing to proceed smoothly ahead of today's OTC-1 burn, 7 minutes and 30 seconds from now. We're now less than 6 minutes away from the OTC-1 burn, which will provide a critical checkout of the Orbital Maneuvering System engine, or OMS engine. It is located on the very bottom of the service module there. You see it on your screen there, located at the very bottom. It's the larger of those engines you see. Today's burn will last less than 30 seconds. Rather right around 30 seconds, but burns can occur with this engine that go up to 16 minutes in length. This OMS engine is the main engine on the European service module and is used to provide primary propulsion for Orion's major in-space maneuvers. The engine will provide about 6,000 pounds of thrust and is equipped to steer the spacecraft and can be used in some abort cases as well to safely return Orion to Earth. And this OMS engine is a repurposed Space Shuttle Orbital Maneuvering System engine that has flown in space before on 19 Space Shuttle flights from 1984 to 2002. We're now about 4 minutes and 30 seconds away from the start of today's burn. Less than 3 minutes until the start of today's OTC burn, which will provide a critical checkout of the Orbital Maneuvering System, or OMS engine, of the Orion spacecraft following its liftoff from the Kennedy Space Center in Florida 7 hours and 42 minutes ago. And as you see here, this mission elapsed time showing that Orion lifted off 7 hours and 43 minutes ago. Still in the beginning part of its journey, as this is a 25-day mission with a splashdown targeted for December 11th. But right now we're about a minute and 20 seconds away from the outbound trajectory correction burn, which again is a critical checkout of the Orbital Maneuvering System engine, or OMS engine. This burn is slated to last about 30 seconds, and everything is still go for today's burn. Less than a minute until the burn is underway. 30 seconds until burn starts. Burn is underway. Hearing good engine performance. And we are getting some imagery of the solar array on Orion as it maneuvers throughout this burn. And the burn has just wrapped up. That was a about 30-second long burn. And we did hear good calls from the team here in Mission Control, good performance from the orbital maneuvering system engine, the main engine on the European service module. Again, that burn was successful, all systems performing as expected, and a good checkout of the orbital maneuvering system engine, or OMS. And with a successful burn and checkout of that OMS engine, that will wrap up our coverage of today's burn. But don't go too far, as we'll be back on the air here shortly to cover expected Earth views from Orion during this outbound coast to the moon. Our coverage of that broadcast will begin at 8:45 a.m. Central, 9:45 a.m. Eastern this morning. And we do expect those live views possible a short time after coverage begins. We hope we'll see you then, but for now, with Orion continuing its journey to the moon following a successful checkout of the OMS engine, that will wrap our coverage for today. This is Mission Control Houston.